This is a demo of a lab where we will learn how engineering teams evaluate AI applications using LangSmith. This lab complements the session on AI evaluations. So if you haven't seen that episode, I highly recommend you do that to understand the basic concepts. In the lab, we will first create a very simple LangGraph workflow and set it up so that every step of the workflow sends traces to LangSmith. Remember, we need traces and logs for AI evaluation, and it doesn't happen during live execution. After creating the workflow and configuring tracing, the next step will be to create an evaluation pipeline. We will create an evaluation dataset, which is also called a golden dataset, with reference test cases and expected outputs, along with metadata that we need for evaluation. We will define multiple evaluators for objective and semantic checks and compare two different versions of our workflow. For semantic checks, we will use a large language model as a judge. As a first step, let us install some libraries. We need LangSmith client libraries for interacting with LangSmith, LangGraph for defining our workflow, and LangChain for various classes that we will use throughout our lab, including connectivity with Amazon Bedrock. In this cell, we are defining the model that we will use for this lab, which is Amazon Nova Pro through Amazon Bedrock. And we are setting up our LangSmith connectivity. Notice that we are setting LangSmith underscore tracing environment variable as true. By doing this and by adding function decorators throughout our lab, we will be able to send the traces to LangSmith without any other custom plumbing. For connecting with LangSmith from the code, we need an API key. So let us see how I've set up the LangSmith environment. I've created a developer account which is free of cost. And if you come under settings, you can create API keys. Another way to create an API key is to go under traces and create a project where you want to send traces for your application. So I've already created a project called Offline Evaluation Demo, where the workflow that we will create will send its traces. You can easily create a project by clicking on project, giving it a name, and from here you can generate an API key. When you create the API key, even from under tracing, it is created at the workspace level and it is applicable for other objects that you will create within LangSmith. LangSmith also allows creating datasets and running experiments on those datasets, and we will explore this later in our lab. Coming back to our setup, let us define a LangSmith client for connecting with LangSmith and set up connectivity with Amazon Bedrock. We are using LangChain's Chat Bedrock Converse API for connecting with Amazon Bedrock. And throughout our lab, we will use LLM for interacting with the large language model. In this lab, we will use Amazon Nova Pro for both answer generation and also for semantic evaluation, where Amazon Nova Pro will also act as a large language model as a judge. In a real-world application, you can have different models for each of these tasks. As a next step, let us create our AI workflow. This is going to be a very simple workflow with 3 steps. 1, retrieve information. 2nd, call a tool. And 3rd, use the retrieved context and tool results to generate an output using a large language model. So we have only 3 nodes here, one for knowledge retrieval, one for tool calling, and the third one for LLM call. For the knowledge base, we have a very simple knowledge base here with 4 documents for PTO policy, VPN access, finance folder, and travel policy. The travel policy says that premium seat booking requires manager approval for employee level L3 and below. This is a use case we will test to fail our workflow. And this is a function for retrieving the context. All it does is it takes the query text, uses the words in that query text to match with these documents. And whichever document has matching words are retrieved. Notice that we are using this function decorator traceable. This will send the trace to LangSmith for this function under the name retrieve_policy. The next function is a mock implementation of a tool call. Here we are taking in a tool type or a request type and returning some hard-coded responses. So we have tool types VPN reset, finance access, travel exception, and unknown. Now let us define our workflow. If you're not familiar with how LangGraph works, there is a concept of agent state, which is the in-process memory that the agent maintains for sharing information between different nodes as they work together. So this is a definition of the agent state for our workflow. This is like a bucket where we define placeholders for saving different types of data. So in our use case, we need the user's request, retrieved context from the knowledge node, tool input, tool output, and final response. After defining the state, the next step is to define nodes in a LangGraph workflow. Each node is a unit of work. In our case, we can divide our workflow execution in 3 different nodes, one for knowledge retrieval, second for tool call, and third node for answer generation by calling the large language model. The second component in LangGraph workflow is an edge that defines the execution flow. If node A is connected with node B through an edge, then node B will execute after node A has been executed. We also have a concept of conditional edges where we evaluate a condition based on input and decide which path to take. In our LangGraph implementation, we have a linear path where we have 3 nodes connected to each other. So let us define our nodes. As a first step, we will create a prompt for our answer generation node, which simply takes the retrieved context and tool output and tells the model to generate an answer. And then we have a helper function that maps the words in the request to different tool types that we saw earlier. If you have VPN in the request, then tool type is VPN underscore reset. If you have premium in the request, then the tool type is travel underscore exception, etc. If you remember, the tool call simply takes these request types and returns some hard-coded response for each one of these. Then we have our first node for the LangGraph, which is knowledge node. And as you can see, we have the traceable function decorator. And here we are calling the retrieve context function by passing in the request. Notice we are passing the request as in the state object, and we are saving the response in the state object. So state becomes our shared context that every node interacts with to get its inputs and save its outputs. We then have the tool node where we are first extracting the tool type by inspecting the request and then invoking that tool. And then we have the final node for our implementation, which is the answer node, where we are calling the large language model. Notice we have 2 flavors of this function. The first flavor is a simple implementation where we are passing the prompt with user request, retrieved context, and tool output, and asking the model to generate a response. We're simply saving the model generated response in the state. In the second implementation, which is a buggy implementation, we are overriding the response with this text, which is your premium seat is approved and already booked for the next week. This will help us test a failure scenario in our evaluation experiment that we will conduct because the company policy says that premium seats do require manager approval. In this function, we are taking in the answer node, which could be one of the two, and defining our workflow. So the workflow is an instance of state graph where we are passing the schema of agent state that we had defined earlier. Then we add the different nodes that we have defined and set up an entry path for our workflow, which is the knowledge node. So when the user request comes in, it first goes to the knowledge node. Then we define edges. There is an edge between knowledge node and tool node and the answer node, and answer node ends the workflow. And then we compile this workflow. We are creating two versions of the agent workflow, one with the original answer node and the second with the buggy answer node. And we're also creating two applications. These applications are required to invoke the workflow. So in the first application, we are invoking the healthy workflow. In the second one, we are invoking the buggy workflow. Okay, so we have defined our application. Now let us test our application and see our traces flow into the project that we had created. So I'm invoking application 1 with this request. What is your refund policy? And as you can see, the traces have started to flow in. Everything is organized under support agent v1 chain. This is because our function decorator on our application says support agent v1. Underneath, we have a node for LangGraph workflow, and every node where we had the function decorator has sent its traces here. For example, the knowledge node, you can come in here and inspect the input and the output. The input here tells us how agent state was when this node was invoked, and output tells us how the agent state was when this node completed its execution. So when the node was executed, we had the request, what is the refund policy? And after we invoke the knowledge node, we have the output, which is these two retrieved context. And this is because our knowledge base had two documents with the keyword policy. So it returned us these documents. Now, similarly, you can look at the tool node and the answer node, which is basically the LLM call. So you can inspect your LLM call, what was sent to the model. We sent a user request, retrieved context, tool output. And the agent responded, I'm sorry, but the provided context and tool output do not contain the information about our refund policy because we did not have any document for refund policy. You can also check the time it took for the model call and the input and output tokens that were sent. So it gives you a complete trace of your model invocation. Let us go back to our lab and create the evaluation pipeline. As a first step, we will create the evaluation dataset that we will use to test the applications. And this is very similar to the unit tests that we create in traditional applications. We have created 3 examples. In this example, we will test the workflow with this request. What is our PTO policy? This is the reference answer, the answer that we expect workflow to generate, which is employees receive 20 vacation days per year and may carry forward up to 5 unused days. This is so because we have our knowledge base with this policy. Then we have the expected tool input, which is unknown. We don't have a tool for PTO policy. The required terms 20 and 5 should be there in our reference answer, and we do not have any forbidden terms here. But in the next example, we have some forbidden terms. So this is an example that we will use to fail our buggy workflow. The request is book me a premium seat for travel next week. And then we have the reference answer, which is premium seating requires manager approval. The required terms are manager approval and forbidden terms are approved, already booked, confirmed premium seat. This will allow us to test that our workflow execution does not have a path to overriding the required policy. Then we have another use case for VPN access. So let's create our evaluation dataset. We can send this evaluation dataset in the LangSmith. So if you come under datasets and experiments, you can create the dataset. And we are doing that in this cell. We are basically creating this evaluation dataset in LangSmith. So if you come here, you will see that we have created a new dataset. However, there are no examples yet, and we will send examples in this cell. So you can see everything that we created in our code has been sent to LangSmith. You can edit this dataset example here within the LangSmith UI. Now we will go back and define our evaluators. These are some helper functions for creating our evaluators. We have 3 objective evaluators. The first one will check the tool selection of the workflow and will match it with the expected tool selection. So this is the actual tool selection and then the expected tool selection, and we will send a score. Similarly, we will check the terms that are returned in the answer node in the trace and match it with the required terms in our golden dataset and create a score. Similarly for forbidden terms. So these are our objective checks that require our golden dataset. And then we have the semantic evaluation, where the evaluation dataset or golden dataset cannot help. This is because no two responses from the large language model will be the same. So we cannot use a golden dataset or evaluation dataset to confidently say that response is accurate. We need a semantic evaluation using a large language model as a judge. So we have created a prompt. You are a strict evaluator, return JSON only. You are grading a support agent response. So if you remember in the presentation, we talked about rubrics that guide the LLM as a judge to evaluate the response. This is what we are doing here. We are basically creating a rubric right in the body of the prompt. We are giving user request, reference answer, actual answer. And this is our rubric that says score from 1 to 5, penalize any unsupported claims, missing key facts, and policy violations, and return a JSON only with the keys, score, and rationale. So this is basically defining the output format so that we can create automation to infer the evaluation results later in this pipeline. We won't do this in the lab, but that is an option. All right, so we have created our evaluators. Now the next step is to actually run the experiments for both versions of our workflow, for application 1 and application 2. And what this will do is this will run applications against the test cases that we have defined in our data set and evaluate the responses using the evaluators we just defined. And if you come here under the data sets, you can see both these evaluations are currently running and coming back. It is still refreshing, so let us give it a minute. All right. So here we can see the 3 entries in the data sets were used to evaluate our application. And these are the scores from individual evaluators for each of these 3 entries. If you're curious why we have this score, you can always go into the actual run. And this is a trace of the actual run that the experiment did. It collected the traces and then ran evaluation. And if you go back to the main screen, you can see both the experiments can be visually compared using these bars. Each of these bars is for each evaluator that we have created. We also have information about latency, P50 and P99, how many seconds it took for each experiment. If you're curious about the actual semantic evaluation and the objective evaluation results, then you can come under tracing. And as you see, we have the evaluators project now. If you come inside, you can see the results of each evaluator. So this is the semantic correctness evaluator. and it called Amazon Nova Pro. And this is the input where we have the prompt. You are a strict evaluator, and the user request, the reference answer, and the actual answer. And we also have our rubric in the body of the prompt. Now the output here is score is 4 and the rationale, which is the response is mostly accurate and relevant, aligning well with the reference answer. However, it could be improved by directly mirroring the conciseness and clarity of the reference answer. So you have a complete rationale behind why that score was given. This is also 5. Here the score is 2. The response does not align with the reference answer and contains unsupported claims. According to the reference answer, premium seating requires manager approval. Now you may question, why is the score 2? Why is not 1? That is because our rubric is very simple. You can have more details in your rubric as to how each evaluation should be scored. Right now there is ambiguity, so it has scored as 2 rather than 1. So this is an example of how you can run your offline evaluation, which can be implemented in your CI/CD pipelines when you're building your AI applications. You can also use it for comparing two versions of your workflow. As a next step, I would encourage you to create a LangSmith account and run this lab on your own. You don't need access to AWS or any other fancy model for this. You can run a model locally on your machine using Olama and run this lab.